Hey everybody, welcome to week 10. We're going live today and we're talking about debugging. So I'm going to talk you through how we would debug. I'll give you a few tips about what I would do if you didn't want to use the debugger and how useful the debugger is. And we're also going to have a look at our utilities class. So what exactly is a utilities class? Why would you use it? And we've already seen one in use. We've seen scanner input, and that's like a class that has helper methods in it that help us out a little bit. And then the big one this week is we're going to start on inheritance. So today we're just going to have a kind of an overview of inheritance, and then on Wednesday Mairead will bring you through all the meaty stuff, and I'll be in the pod on Wednesday answering your questions. Okay, so without further ado, let's get started on this week. So we're looking at programming, our program fundamentals, and we're looking at introduction this week. So we're going to look at utilities, debugging and inheritance. So let's get started. So what are utilities, to make sure that everybody is okay so far? If anyone has any questions, or can you hear me? Okay, good. So what are utilities? So utilities is just the name that we give to a class that's going to help you in some way. So you'll see later on today, we're going to look at the different packages and starting to create folders that we will put our code into, our classes into, to keep them together in folders that make sense. One of those folders may be utils folder or helpers folder, whatever you want to call it, and inside of that will be classes that contain methods that can be used over and over again in different classes and in the classes that we are creating as well. So what we might do is we might come across a method that we need. So we're creating our product class, and in it needs to have some way of ensuring that the index is valid, or the ID is valid. So we might create a method in our product, and then we'll say, actually, you know what? If I change that code slightly, it could be reused in other classes. And this is where this idea of a utilities class comes in. We would put the code into it, the methods into it, that we could reuse elsewhere. So code like, checking to see is a number within a certain range, checking to see if a string contains numbers, all numbers or all letters, checking to see if a string is a certain length. So these are all pieces of code that we could use and reuse over and over again, but only write once. Okay. So in our product, we have validation, and the validation that we have written so far is we're checking to make sure that the code must be between 1000 and 999. So we have this piece of code here that says if the product code is greater than or equal to 1000 and the product code is less than or equal to 999, then we're going to store it. So just to remember what exactly validation is. Validation is when we ensure that the information that we're storing isn't junk. So we're storing data or storing information or fields that makes sense, that passes a certain test that we have put in. Okay, and this is a validation in our constructor. So a lot of people are asking, why are we putting stuff in our constructor? Why are we putting stuff into our setter? Where is the validation going? Why are we calling our setter in our constructor? So we put validation in our constructor because we want to ensure that the information that we take in, the data that we take in, is valid. So when we're creating our object, we create it with valid information. We put validation in our setters because we want to ensure that when we update our object, we're updating it correctly, we're updating it with valid information, we're not storing anything that's invalid. So there are two different things. Our constructor is when we create it and we're making sure the data is valid there. Our setter is after that, when we're updating it, we're making sure that it's there, it's valid there. So we will have our validation in both places. So the next question is, and why sometimes are we calling the setter from our constructor? And that's a really good question. Why are we doing that? Well, first of all, we don't need to. Okay, we can just write the code in our constructor and we can write it again in our setter. But remember, one of the principles of coding is dry. Don't repeat yourself. So if we have a piece of code that's the same in our constructor and it's the same in our setter, what we're doing is we're just calling that piece of code again. So we're only writing it once and we're calling it. So that's why sometimes you will see a call to your setter in your constructor, and that's just there because the code is in the setter was the same as what was written in your constructor. So you don't need to write it again, you can just call it. Okay, but if that doesn't make sense to you, then just write it twice, and as you get more and more confident, you'll know, okay, I've already written that in the setter, I only need to have it once, I'll just call it from my constructor. Okay, so let's get back to our validating of the product code. So at the moment, in our constructor and in our setter, we have this piece of code that's written there. Okay, so this is why we're saying don't repeat yourself. So the same piece of code is there twice. So you can see here, it validates it here and ensures that it's right when we create the object, and also it's the same piece of code here. Okay, so in that case there, we're just going to call our setter here. Okay, so what's a utility class? So a utility class and helper methods, we use them to avoid repeated code like this. So we can write a helper and it'll perform the validation for us, and then we'll just reuse it. We'll call it again and again and again. And we try to make these helper methods as reusable as possible. So what that means is we don't pass it field names. We don't have field names in the method. We pass it the information and then it deals with it. So we generally store these reusable helper methods in utility classes. And these utility classes can then be reused in any of our future products. Any project can have any number of utility classes, and we already saw last week our scanner input, and it's a utility class. And remember it has calls, it has methods that are static that we can call from our code. Okay, so here's a utilities class that we're going to give you. So you can see here it says package utils. So later today we're going to find out what that means, but that means that we're going to create a folder in our code called utils, and into that we're going to put our helper classes, and in this case our utilities class. Public class utilities, exactly the same, we're just giving it a name. We're calling it utilities because that's what it is. It's a lot of different kind of methods. You can give it your own name. Okay, it doesn't have to be called utilities, but that's what it is. And then we have our Java doc, and remember we said what our Java doc was last week. It just gives an instruction so that we can create a document for this method. When it's placed directly in front of our method or above our method, then that's the information for this method. It's extremely important when we're creating utility methods in our utilities class that we comment them correctly, because remember these are going to be reused hopefully over and over again to save you or other people in your organization time, because if we have methods that can be reused and that we test correctly, therefore the people who are using them don't have to try and figure out the code for it again. They just reuse this and know that when they put in a value, they get the correct answer. So in this case here, we have a method called valid range. Valid range accepts 3 ints. So as parameters are going to be passed, we're going to pass it 3 ints. The first int, we're going to call it internally here number to check. The second int is going to be our min, so that's just going to be a name that we're given to it in here. And the third int, we're going to call it max in here. So there are 3 values, our 3 parameters. This method returns a boolean. So it's going to do something and then it's going to return true or false. It's public because it needs to be public because we want to access it from other places, from other classes. And then we have our keyword static. And the reason why this method is static is because we don't want to create an instance of utilities to use it. So static means that there's only one method, valid range. It belongs to the class utilities. So to use it, we're going to say utilities.validRange and pass it the 3 numbers, and it's going to return true or false. So this here is our parameters and this is our return. So again, we could, if we wanted to put this code into it, and this is very similar to our code that we were looking at up here. So you can see here that we're testing this product code here. So this is what we're going to test, and this is going to be the minimum value, and this is going to be the maximum value it can be. So instead of writing this everywhere, anywhere that we need to have a number that's valid, we can just call this method here. So in here, remember we said that it's the same code, so that we can just put the code into our setter. So in our setter, we're saying if utilities dot valid range, so that's the method that we just looked at. Remember, it expects 3 parameters. The first parameter is going to be the number that we're checking. The second parameter is going to be the minimum, and the third parameter is going to be the max. And we're saying if, when we call this method, it returns a true, then we're going to store the product code that was passed in. It's a valid product code. If it returns a false, we're not doing anything with it. So in that case, if this was called in the constructor, it's going to store the product code as -1 because that's the default. When we created this, we gave it a default of -1, and it's only updated if the product code that's passed in is a valid product code. So you can see here we're calling our utilities, and up here to call it, we're importing it. So we're telling our class where to find this utilities class. It's in the utils package and it's called utilities. Okay, so now we also have some helper methods to help us with validating strings. So again, we've already written this code in our shop, and where we check the length. If the length is less than or equal to 20, we're storing the product code, and if it's not less than or equal to 20, in our constructor we are truncating it. We're taking the first 20 characters. In our setter, in this case, the code is slightly different. We only store the product name, we only update the product name if it's less than or equal to 20. So if the length is greater than 20 chars, when we go to update it, we don't change it. So when we're creating the object, our rule is slightly different. Our rule states that if it's less than or equal to 20, yay, it's a valid name. Otherwise, just give me the first 20 characters. After we create the object, if we need to change the product name after that, we were going to call the setter. And that's where we say, We're only changing it if it's less than or equal to 20. So let's have a look at the methods that we're going to have for those. So in our utilities, we're going to have two new methods, one called truncate string, and let's see what that one does. It's public, it's static, so it belongs to the class. It returns a string, so whatever happens in here, it's going to return a string. It's called truncate string, and this one expects us to pass it in a string and the length that that string needs to be. So what we're saying here is, if this string that we pass it in, if the length is less than or equal to whatever the length is supposed to be, then we will return it. So that's great. That's a valid string. It's less than or equal to what it's supposed to be, so we're going to return it. We don't have to do anything with it. Otherwise, what are we doing? We're getting the string that's passed in. We're getting the substring. So remember what substring is. It's a method of a string. It expects the two parameters. It's passing in 0, so we're starting at element 0 and we're stopping at the length. So that's going to give us the first, in this case here, 20 characters if that's what we pass in. So that's going to return a string, and the string is going to be the same string if it's less than or equal to 20, or it's going to be the first 20 characters if it's more than 20. If you try to use a substring on a string that's less than what the length, then you will get your program will crash. So that's why we check it first. We only do the substring if it's greater than or equal to whatever this length is here. In this case, we know it's 20. Okay, and then, and then in our validate string length, this is another new one. We're going to pass it in the string that we want to check. So just note the different names. Doesn't matter what you call them, but we're saying that the first string here we're passing in, we're going to call it stir to check, and then this one is our max length. And this is only going to return true or false depending on whether it's less than or equal to the max length. So if you think about it, this one here does the job in the constructor, and this one here can do the job in the setter. So in the constructor we said that it's allowed truncated. So look how neat our code is starting to look. We're calling our utilities class, we're calling the method truncate string, we're passing it the product name that we're passing in, we're telling it a 20 because that's going to be the max length, and it's going to return the first 20 characters if it's greater than 20, or the actual name that was passed to it if it was less than 20. And for our setter, we're going to call our utilities.validate string length, pass it in the product name 20, and if that returns a true, because remember the validate string length returns true or false, so if it returns true, it's less than 20, then that's good to go, we can store it. If it returns false, we're doing nothing with it, because our rules tell us that we don't truncate in the setter, we're only truncating in our constructor. Okay, so that's our utilities class. So what we're going to do is, I might see, have I got the utilities class just to show you? Let me see. Okay. So we're going to go through this later on, the different packages, but you can see here this is our shop version 5. We have our models, and this isn't working properly, so I'll have to fix it. And we can see that we have in our utils folder, we have our scanner input class, and we have our utilities class. And in our utilities class, we have methods that you can use in your code that are going to help you. And that will save you having to write the same thing over and over again. So up until now, we've been doing checking to see, did the user enter a Y or an N? And you've been doing the conversion. Well, now here you go. Here's a method that you can call that will help you with that. Again, if they enter a Boolean, it's going to return a true or a false. This is our truncate string, our validate string. This one is a valid range, so it's going to return true or false depending on whether it's a valid range. So what I'd like you to do is, when you get a chance, have a look at the utilities class. I know last week's notes in the labs, you would have been using this as well. So just to see where it's being used, but as long as you understand that we create these utilities, just so put the methods into the utilities class, just to make our life a little bit easier, because the more that we can reuse methods and not have to write them again, the better. Over the next couple of weeks, we're going to start in our JUnit testing, and you'll see that once we test the utilities class and we know that when we pass it different values that it works correctly at all times, that means that when it's used in our code, we have a little less testing to do because we know that that code works. So it's really beneficial to you as a developer to start keeping your own utilities classes. So as you're doing projects, go, you know what, that was a really nifty method that I wrote. I'm going to make sure that that's generic enough that I can create a static method, and I'll be able to call that or reuse that in other assignments as the time goes on. Okay, so if you've any questions, give Mairead a shout there. She's dying to answer them, and we'll keep motoring on here today. Okay, debugging, one of my favourite things to do. I don't know why. I used to work in a company where I did production support, and production support is a lot of going through other people's code, finding where they made mistakes and fixing it. And it was just something I was very good at. I could see things straight away, and so I get a real kick out of debugging code and trying to find where things aren't doing what they're supposed to do. So today we're going to have a look at the debugging tool that comes with IntelliJ, and I'll also show you just things that I used to do when I'm debugging as well. And we're using a very simple example, but you can imagine that if your code was calling lots of different classes and using lots of different pieces of code from other places, how important it is to be able to debug correctly, to be able to find where the issue is being introduced, because that can be like, I mean, we've seen what happens when we have a curly brace in the wrong place. So you can imagine if your code is running and there's a curly brace in the wrong, curly bracket in the wrong place in thousands of lines of code, how hard it is to find that without a tool. Okay, so we'll have a look at that. So what are bugs, what are debuggers, and how do I use them? So let's have a look and see. So a software bug is an error or flaw or a failure or fault in a computer program or system that causes it to produce an incorrect or unexpected result, or to behave in an unintended way. So code that we write, it's kind of hard to write code without bugs, okay? Because when you're writing code, if you know, sometimes it's just he said, she said. So, you know, there's a misunderstanding of what actually is expected. Or you didn't take something into account when you were writing your code. You didn't know that, you know, you were told that every day the interest rate is going to be 0.48%. So you wrote your code for 0.48%, but actually it's every day except on one day, leap year, once in 4 years. On that day, it's 0.47. And you didn't know that. And all of a sudden, on that day, everything goes astray. So these are bugs that are introduced into our code. And again, we need to be able to find them. So they can be very frustrating to find and fix. And it takes a lot of patience to be able to find some of your bugs. Sometimes you look at something and you can tell straight away, okay, and the one that we're going to do today, you don't need a debugger for, you could tell straight away. But in organizations where you're taking data from a lot of different places and a lot of different sources, so user input, files, databases, it can be really frustrating to find where exactly the bug has been introduced. So we have a debugger, and a debugger can be used to fix bugs, okay? Well, to find errors, to find the bugs so that you can fix them. So it's a software tool that helps in examining how the application executes. It allows programmers execute an application one statement at a time, so we get to walk through our code. And actually, a debugger is brilliant if you're given a piece of code. So like, you have the social network or the shop, and you don't really understand what's happening. Just use a debugger to step through it step by step, even though there's no bug in it, step through it step by step. All of a sudden you can say, oh, so that's how it calls that. Oh, so that's where it gets the name from. All right, that makes sense. So actually just using the debugger to go through code that you've been given to help in your understanding, brilliant, I love it. Okay, so we can step into, we can step out of. So typically provides functions to stop and start a program at selected points in the source code, and that's called breakpoints. We examine the values of variables, so we can have a look and see, okay, what value is an I now? What value is an I now? What value is an I now? So when it's gone around in a loop, we can make sure that it's executing the loop correctly. Maybe we forgot to change the value of I, and now it's always going to be the same value. So we can examine the values of variables. Okay, so debuggers are especially useful when your program contains logical errors. If you've got a syntax error, grand, you're going to see it straight away. But when it's got a logical error, so these are errors that compiler doesn't pick up. So the syntax is great, the syntax is right, but it's just not doing, the logic isn't right. Okay, so debuggers are great to be able to find those. And using the debugger, you can trace how each of the calculations, changes made to fields, variables happen, and hopefully figure out where the error is occurring. So how do you use them? Okay, so most IDEs come with a debugger. IntelliJ has one, and we're going to learn to use that. And we're going to use the IntelliJ debugger to step through the debugging of a small program. Okay, the program iterates over a primitive array of int and prints out the largest number in the array. Okay, so here's our code. So it's creating a list, an array called list, and each element is an int. And here we say we create our array to have 4 elements. Element 0 is 2, 1 is 5, 3 and 4. So it has 4 elements, 2, 5, 3, 4. And what we want to do is we want to find the largest of those by calling this method largest and calling the static method find largest, which takes a list, goes through it and returns the maximum value. Okay, so we're expecting when we run this 5, but when we run it we get this value here. Okay, so I'm going to leave the PowerPoint presentation first here, and what I'm going to do is I'm going to do it in IntelliJ. You will have your notes that you can look at in PowerPoint, and then we'll talk you through in IntelliJ this. Okay, so let's see. So let's just run it first and see what happens. So if I just run this here, this is our code. It has driver and largest. If I'm running driver, I'm passing in 2, 5, 3 and 4, which was our array. It's calling this largest.find. It's executing this code, and instead of doing 5, it's returning this really large number. Okay, so if, to get started, before we look at the debugger, if you think you can kind of have an idea where it might be, okay, what I sometimes do is I would come into where I think it is, and I would have a system.out. So I would print out maybe the value that's in the index. And then when I run it, I'm able to see what the value is. Is the value changing? And that might sometimes give me a little bit of help. So this is just it without using the debugger. And you can see it prints out 2, 5, 3 and 4. So we know it's going through the list correctly, but it's still giving us this value. So if I didn't want to use the debugger, I could probably quickly figure out what's wrong there. So printout statements are great to help you, okay, but they only go so far. So let's get rid of that for a second. So what we want to do is we want to be able to use the debugger. So we know that when we call this line here, it's not returning the correct value there. So what I'm going to do is I'm going to just click here beside 5 and see the way the red dot appears. I'm just going to get rid of my person there for a second so you can see the full thing. So you see this red dot that's now after appearing? That's what we call a breakpoint. And that's what we're doing, is we're telling our code, when we run, I want you to stop at that point. Okay, so now we want to run this. If I just use this run here, so if I use our normal run, it'll just run it without stopping. But if I click down, oops, if I click on this one here, see where it says debug driver, and run it, it now stops where I have told it to stop. So it's now stopping at our breakpoint. Okay, so you can see here it has stopped at line 5 because that's where we told it to stop. So now what we want to do is we want to step into it. So if we come down here to the bottom, so if we just have a look here, okay, so we'll see here, this is step over, step in and step out. So what we want to do now is we want to step into our code. Okay, so we're going to choose to step into it, and you can see here it's after coming in to find largest and it's stepping in to find largest. When we go down to our expressions, our threads here, our variables, we can click and we can it's telling us that we're passing it in an int that has 4 elements, and the 4 elements are 2, 5, 3 and 4, and we can see them there. And the length of our list is 4. Okay, as we step through it, we'll see that next line it's going to create a variable here called index and give it 0. So we'll keep saying step into. So now we have index and we give that a value of 0. We'll keep going. Now we have a variable called max. So for those of us amongst us, we might see that there may be a little bit of an issue there, because that's the value we're getting back the whole time. So it has this, our value. So as we keep stepping into it, we'll see how it changes. So let's keep stepping into it. So we're going to go into our for loop. Okay, so we have our index is 0 because we created it here. Index is less than the index.length, so the length of our index is 4, 0 is less than 4. Okay, we don't do that until we get here to the end. And it says if in our list at element index, at element 0, so that's going to be 2, is greater than max. So let's see what happens there. Oh, that's not greater than max, so that's okay. So we'll keep going. So the next time is list index. So list index is 5, so that's the one that we're looking at here. Is that greater than max? Well, max is 21474 is the maximum value an integer can be. So it's not. So let's keep going. The next one is 3, it's not greater. 4 is not greater. So straight away we can see that nothing is ever going to be greater than the max value. So we made a mistake by using that. Okay, it's always going to be the largest. Okay. So once we're happy that we know we could step out of it, okay, because we know what's wrong and we can keep going, we can step over, or if we want we can rerun it, or we can play till the end. We can just resume it because now we know what's wrong, and you can see it printed out the largest number. So if we go back and fix it, okay, so instead of in our largest having this, because we saw that that was where the problem was, okay, we can do two things. We could either say that it's equal to the min value, okay, so that's one way of fixing it, or we can say, oops, it's equal to the first value in here. So it's equal to okay, so there's two ways of fixing it, and what we'll do is we'll run through it with both of them. So if we set it to the min value and we run it, it's printing the right value here. So let's go back and debug and see why it's doing that. So we can see here we're here, so we want to step into it, so we're going to step into it. We're coming in here, we're going to keep stepping. Now max has a very small value. It has a minus value. So it has the smallest value it can possibly be. So therefore, every integer is going to be bigger than that. So we're going to find our max. So if we step into it, we can see, is list index, so list index is 2, is that greater than minus whatever? Yes, it is. So now our max is equal to 2. So when we go to the next one, we'll see max is equal to 2 because it was equal to the first one, because it was bigger than the minimum value. And now we go to the next one. The next one is 5. Is 5 bigger than 2? Yes, it is. So therefore max is now equal to 5. Then we go to the next one. The next one is 3. Is 3 greater than it? No, it's not. So it skips, goes to the next one. Is 4 greater than it? No, it's not. So at the end, when we get to here, it has the max value of 5. So that's what's going to get returned. And we can keep going to the end, and it returns 5. Okay, so that's using the min value. And if we use this one, it does the same thing. It says the largest number is 5, because remember what it does is it's just saying the smallest one is the first one, is the first element, and then it tries to find anything that's bigger than that. So it does a similar thing. So if we have a look down here, just run it again, sorry. So here is our buttons, and as I said, this one is if we want to rerun it. This one is if we want to stop it. So we found the problem, we want to stop, and we're going to change it or whatever. This one here is resume. So we're not stepping through it anymore, and it will resume it until the end or the next breakpoint. So if you can have more than one breakpoint in your code. This one means step over. So if you don't want to go into a certain method or a certain piece of code, you can just step over it or step out, step over a loop or whatever. This is the one we were looking at. We were stepping into it. We were going into it step by step. And this one here is when we want to step out. So we're in a loop and we want to step out of the loop and continue on with the next line of code. Okay. So if we have more than breakpoints, we can have a look at that. Okay. So that's the notes have what we've just gone through there. So if you want, you can go through. If you want, you can go through the notes and the PowerPoint slides that we have up, and that just walks through what we're after doing there in IntelliJ. But you can see here how we set it up, how we write the code, how we create the breakpoints, and as I said, it's really useful for when we're trying to figure out how information gets passed around, because we can step into it and see what's happening at each line of our code. So, when we give you code or, you do something in your lab and you're not 100% sure, just debug it and have a look and see. Have a look down here in our threads and our expressions and see what value our variable has at that moment in time. Okay, and as you can see, as you go through each line, the new variables are created, and then as you come out of this one, you'll see that max no longer is there. Okay, so that's really useful. Okay, so let's keep going, I think. So I'll tell you what we'll do. We'll just take a quick break. So we'll just take 3 minutes just to give you a little bit of a break if you want to go have a toilet break or grab a cup of coffee, and we'll be back to you then. And we're back. So I just had a quick chat with Mairead. It's great to catch up. So we're going to start on inheritance. So before we get started on inheritance, we're going to have a quick look over SHOP version 3. Thanks, Mairead. SHOP version 3. Or sorry, social network version 3. So last week I asked you in your labs is just to go back and have a look and make sure that you could do social network version 3. And the reason for that is because we're going to build on that over the next 2 lectures. So we're going to take what you have done and we're going to go a little bit further and show you how inheritance works on an example. So let me see. So you had in your labs maybe social network version 1, but we're going to we don't need to do that. Okay, so we're going to have a quick look over social network version 3, and you would have seen this. There was an extra lab session in week 9, and that will bring you through the social network. So it's a small prototype social network. So it's like WhatsApp without, that's not very interesting. And it just supports news feeds with posts. So what we're creating is we're creating a small app that supports some sort of news feeds. And, at the start in social network version 3, it has a message, which is just a multi-line message. And for that message, we were able to add it to our feed, display it, and remove it. Okay, so that's where we've left it. So it had a little menu, and it had a controller, a driver, it had a model of a message post, and it had scanner input and utilities. So again, this layout, this design pattern, we're going to have a look at again. But these packages are just ways of starting to bring our code together and starting to put our code into logical folders as such. Okay, so we're having a look at our message post. Okay, so before we get started there, I'm just going to see, can I find version 3 and just to show it to you. Okay. Now, I don't know why this is doing this. I'm going to have a look and see. So this was our message post, and in we have a class that keeps track of messages. So we have a constructor which constructs a message, and it's going to have an author and a message. We're able to get the author, so we have our setters and our getters, our get messages, our setters for getting, and then we have this idea of likes. So how many people who've read our message likes our message. In our controller, we have our news feed, and here we can see that we have an array list. Each element of our array list is a message post, and we're calling it posts. Then we can add a post, so we pass it in a post, a message post, and we just add it to our array list. We can show it, so we can go through each element in our array list, and we can show each element of it, and if it's empty it'll say no posts, otherwise it'll return all of our messages. So I just want to make sure that you understand this here. This is our for each. So our for each is just a simpler way of writing our for loop, and we've been kind of used to doing it a little bit like this. So we would say for, and then we have our LCV, I is equal to 0, I is less than post.size, I++, and then we'd say stir plus equals, and then we'd say post.get. Okay, whereas here, or sorry, we're saying post.get, and we'd say dot, oops, sorry. So here we're going through we're using our for loop, and we're getting each element. So you can see here, our for each here is a much nicer way of writing that. So again, you would have done this in your version 3. Our delete message, we're passing in the index we want to delete. We're checking if it's a valid index. So we're calling our isValidIndex, and then we're removing it. So remember, our array list has methods that allows us to add and remove, set, lots of different methods. One of them is the remove. We tell it what index we want to remove. So whereabouts in our array list, what element we want to be deleted. Okay, you have your update and your find. So that's in your newsfeed, and then in your driver, we have the code written that allows us to interact with the user. So go into your chipper and you see your menu of what chips you want to buy, or what chicken burgers or whatever it is. This is the same idea. This is where our user sees the menu and interacts with it and asks, you know, I want to add a message. They write in the message, and then that message is passed to our controller, our news feed, and it's added to the array list. Okay, so you can have a look at this code yourself. It's very similar to our shop, except it's a new idea. It's creating this idea of messages. Okay, so let's see, go back here for a sec. Okay, so this here was our news feed that we were just looking at. Okay, so this is what it's going to create. It's going to create a post. So when we go to call the display, it's going to display all of the messages that have been added to our array list. So this is my first post, this is my second post, this is my third post, this is my fourth post. Okay, so again, not overly interesting because it's just text, but I don't know if any of you can remember back to when mobile phones actually got text messages. At the start it was just text, and then we were able to have an image, and then you were able to add a video. So this is where we're starting. We're starting with just having a messages. Okay, so they're all our posts, and you can see that they're just all text. But that's not overly interesting. So what we're going to do is we're going to move on with Social Network version 4. And what we're going to do here is we're going to add in the ability to have different types of posts. So we're going to have our message post, and we're also going to have our photo post. So you can see here, that's my buddy. So if I was sending myself a message, okay, this here is my messages, and then I have a nice photo of Buddy to put a smile on my face, and then another message. So this is more like what we want. We want to be able to have different types of messages in our social network. So what is version 4? It's still a prototype social network. It still supports news feeds with posts, except now we have a message post and we have a photo post. So our message post is going to have text messages, and the fields that are going to be in our photo post are linked to where the photo is, and maybe a caption. Now, there's no caption on that, but it would be like, you know, lovely Buddy. So, and a caption for our photo. So we're taking version 3 and we're going to add to it with version 4. So what are the operations? Well, we're still going to be able to search, display and remove. So except now we're going to be able to search for messages, for message posts, and we're going to be able to search for photo posts. We're going to be able to display message posts and display photo posts, and we're going to be able to remove message posts and remove photo posts. So we want it to look a little bit like this. So we want to be able to have a message, a photo with a caption, a message, and a message maybe. So these are all our posts, and this is our text. So they're all posts, but this one is a photo post, and these are message posts. And this is our caption on our photo post. I should say first photo. So look how our diagram is going to change slightly. So if we think of it before, we had, I'll just get rid of myself there for a sec. So before we had a driver, our newsfeed, and we had our message post. Now we're going to introduce this class photo post. And in our class for photo post, it's going to have our fields, our author, our likes, and it's also going to have our caption and the location of the photo. So this is our example of our message post, and our photo is going to have a picture and a caption. So you can see here we have two objects now, or two classes. One called message, and it has an author, a message, and like. So that's what you've been using up until now. But now we're introducing this photo post, and you can see it too has an author, it has a caption, it has a file name, this is where the photo is going to be, and it also has likes. Okay, so we can see here that both have authors and both have likes. But we don't know anything about inheritance yet. So we don't know that we can do something with it because we haven't introduced it. But just to be aware that already we can see that there's similarities. Okay, so now we're going to have this class structure. So we're going to have a class called message posts, which is what we have here. We have our message post. So this is our class for our message post. So that's not going to change. But now we're going to have a class for the photo post. So we're also going to have another class, and this other class has a constructor. It has a setter for getter, a setter and getter for author, a setter and getter for caption, a setter and getter for file name, a setter and getter for likes. It has a display, and it has the fields author, author. It has caption and file name, and it has likes. Okay, so this here is our object for message post, and this here is going to be our object for photo post. So social network version 4 is going to have a class that's going to allow us to store messages, and a class that we can create photos objects from. Okay, but already we can see the duplication of effort. So we can see that we have author in both, and we have a setter and a getter for both. And remember what we said when we're talking about utilities. We said dry. We want to keep our code dry. Don't repeat yourself. And here we are, we're writing the same stuff in two classes. Our likes, we have a field called likes. And in here we have our setter and our getter for likes. But here's where it starts to get really, difficult to manage, because before we had in our newsfeed we had an array list of messages, but now we also need to have an array list of photos, because we're going to have lists of photos in it, and we haven't introduced inheritance, so we have to have an array list of message post. Each element in that is going to be a message post, and we're going to have an array list of photo post, and each element in here is going to be a photo post object. So now in our newsfeed, we have 2 array lists that we need to keep track of, 2 array lists that we need to add to, 2 array lists that we need to delete from, 2 array lists that we need to display. Okay, things can start getting complicated fairly quickly. So if we look at version 3, our newsfeed had an array list of posts. So it had 1 array list here. But now, because we have 2 array lists, 1 for message and 1 for post, you can see that we need to duplicate everything. So we need to have an add message post and add photo post. So we're going to add to a message to our messages. We're going to add a photo to our photo. We're going to have 2 shows. We have 2 deletes. We have 2 updates. We have 2 finds. We have 2 numbers. We have a load and a save. That's fine. We have 2 as valids. So now what was here has now been duplicated, and we have twice as much as we need to have. So to handle the 2 array lists, our newsfeed methods have grown significantly. Now delete has 2 methods, so we see our delete has 2 methods. Our driver is okay. So our driver, we're going to add a message, we're going to update it, we're going to add a photo, we're going to update it, we're going to list. So our version 3 versus version 4 of our driver, probably no matter what's happening under the hood, to a certain degree, what the user sees mightn't be much different from a menu point of view. Okay, so again here, the add, the message, update. So in version 3 we had 1 add message, but because we have a photo and a message, we now have 2 add photo and add message. So you can see here our show in our newsfeed. This one here is going to go through our message posts, and it goes through our photo posts, and it's going to display all the messages and then all of the photos. So just to think about that, is that how our newsfeed normally works? We see all of our messages and all of our photos? It's not, because if you think back to at the start when we had our picture of Buddy and we had our messages and the photos were in between messages. So when we look at our messages on our newsfeed, we don't see all of our messages of one type. We see a photo, an event, a message, a photo, etc. So they're intermingled. Okay, so you can see here the problem is the posts are not displayed in the order they were added. All the messages are displayed first, followed by all of the photos. So you can see here it shows all of the messages and then all of the photos, because that's what we're telling it here. Because they're 2 different array lists, it's showing them, it's showing all of one then all of another. Now I hear you say you could have some sort of timestamp in, and you could go through them and find the next timestamp in the next list and show that, and then go back up again and not try find the next time list, whichever list it's in, and show that. Yeah, absolutely you can, but you can see you're adding in complexity where actually we can code it without adding that complexity. Okay. So our social network version 4, what's wrong with it? Okay, it does what we want. It's got the messages, great. It has a new class for photos, brilliant. Now we can see our pictures of Buddy, and I have quite a lot if anybody wants to see them. Now we can see our pictures, but they're both very similar classes. In fact, large parts of their code are identical. This means that when we need to change something, we have to change it in both places. So it can make maintenance difficult and it can give the developers more work. And here's our bugs. It introduces the danger of bugs through incorrect maintenance. So if we only update the code for likes in photo but don't update the code for likes in message, now our code is out of sync. And we're introducing bugs, we're introducing, just making it all the more maintaining more difficult. And there's code duplication in newsfeed and driver. So we need a better solution. And the better solution is, thankfully, inheritance. So let's have a look at what inheritance is. Okay, we don't need that. Okay. So what is inheritance? So we're going to go back to social network in our next deck of slides. Yeah, deck of slides, isn't it? But anyway, in our next slides. But before that, we're just going to have a little introduction as to what exactly inheritance is and how we use it and how we are able to identify the classes that we can use it in, because we can write code without using inheritance. And you've just seen it in social network. You could write the social network, you could figure out a way of doing it without inheritance. You'd have lots of duplication of code. You would have maybe a little bit of a maintenance headache, but you're so what? The code works, it does what it's supposed to do. It may not be the best way, but so what? Whereas now what we're going to do is we're going to show you a better way of doing it by using inheritance. So what is inheritance? So inheritance is a fundamental feature of object-oriented programming that allows a class to inherit properties and behaviours from another class. Okay, so let's think about that. It allows a class to inherit properties and behaviours from another class. So that means that we can write code, put it into a class, and that would be the general code. So code fields that are shared across different things, and that would be in the general part. And then the different things, i.e. the more specific classes, would inherit that general information. Okay, so it allows us to inherit properties and behaviours from another class. It promotes code reusability. So it allows us to organise our classes to be built on existing classes. So we can stand on the shoulders of giants. So what I'm saying is that if you're reusing the code, okay, that code can be tested, it can be checked to make sure it's right, and then we can extend that code and add in the fields, extra fields that are required. Okay. So this is our basic person, okay? So if you were asked, okay, you've been asked to create create a program, and it's for some sort of recruitment firm, and you want to be able to store the information on the different types of people that you're going to find jobs for. So what would you do? So you'd start off and you'd write out a list of all of the information you'd need to save. Okay, so you'd say, well, we need to know their name, we need to know their PPS number, we need to know, I don't know, you need to know their next of kin or whatever it is. We need to know their email, we need to know their phone number. Okay, and then you say, okay, well, a programmer, we need to know programming languages. And that's for the programmer. Can't spell. we might need to know the group, you know, for the dancer, we might need to know their current group name. And that's for the dancer. And for the singer, you might need to know if they're in a band, and so on, you know, type of singer maybe. Whether they sing pop or classical or whatever it is. So you'd go through it and you decide, okay, well, this is all the information I need to store on the different people. And then what we'd say is any of the information that's general, so we need to store that on everybody. We could put that in a class by itself, and then whatever is unique to the other people, they go in to the other class. So we come up with our list of all of the information that we need to store in our system, and then we break it down and we say, okay, well, what's general to everybody, what's just for the programmers, what's just for the dancers, what's just for the singer. And that allow us to be able to use inheritance. If not, if we don't use inheritance, then the programmer is going to have all of the general information plus his own extra fields. The dancer is going to have all of the general information plus their own fields. The singer is going to have all of the general information plus their own fields. So we want to be able to identify what is the general information, what can be included in all of them, and we'll create a class and allow those other classes inherit that. Okay? Okay. So when we do that and we create our general class, so the class that has all the general information, in this case, we call that our parent class. So this is our person, and we call that our super class or base class. So when you're researching this or when you're listening to us talk, we'll either say parent class, super class, base class. And that is a class that has other classes inheriting from it. So it defines common properties and behaviours shared by multiple classes. And as I said, it can be referred to as a superclass or a base class. Child classes. So these are also called subclasses or derived classes. So they inherit properties and behaviours from the parent class, and they can have its own additional properties and behaviours. So again, this is our parent class or our superclass, and these are our child classes or our subclasses. So these are classes that can inherit from the parent class and can have its own additional properties and behaviours. Okay, so when we create our class, we say our public, okay, class, and the name of our class. So that's what you've been doing so far. We've been creating classes, we've been giving them a name, and then you've been writing fields. So public class product, public class shop, public class newsfeed, whatever it is, and then we've added in the fields. Well, now we're introducing this new keyword extends, and we're saying create this class and it's going to extend another class. So if this was the name of our superclass or our parent class, well, then we're saying public class child extends parent. Okay, so again, these are just names of classes. So the keyword extends, this is a new one. It indicates that the class is inheriting from another class. So whatever the class name is, it's going to extend the parent. It's going to inherit from the parent. And then that will be the name of the class. So this is our person example. So we can see here that this is this person here. So public class person, all of the general information is going to go in here. We're just stuck with name. So we're saying string name, so this is the general information. Our constructor for the person, so when we create a person, we're going to construct it with a name. And then we have this idea of learn, eat, walk. So these are just we would create our setters and our getters here, but I haven't added them in. And then these methods here are methods that everybody has. These are all the general methods. So learn, we're just going to say learn loads. Eat, we're going to say eats too much. And walk probably doesn't walk enough. Okay, again, these should be probably strings, because we keep telling you in your model class don't have any system.out.printlns, just have those in your main. So this kind of goes against that, but this is just for an example. Okay, so and then we have our toString. Now you'll note that our toString has this thing called @override. Okay, so I don't know whether any of you have ever wondered what that means. What that means is that this toString has been written before and we're overriding that version. So without you knowing it, every time you create a class, it automatically inherits from a class called object. But you don't have to say extends object, it automatically does that. So every class that's created automatically extends object. In object, there is a method called toString, and it returns a string. Now, if anybody calls that doesn't override it here, you'll see that when you call the toString, it has like an address is what's returned. Whereas when we override it, so what we're saying is, I know there's a toString for object, but I want to override it, I want to change it. And when I call the toString for a person object, I want you to use this one here. This is what I want returned. Okay, so that's what the override means. It's when we're overriding a version that we have extended from, and we always extend from object even though we don't say it. So now we have our programmer, and we say our class programmer extends person. So that means that they're getting the information and the methods that are in here. And you can see here that when we create an instance of programmer, we pass it in the information it needs for person, and our first call is this super. So what is super? So super is in our constructor, we're calling the super classes constructor. So we're calling this here. We're passing it in the information it needs, and it's going to deal with the name. It'll validate it, it'll do whatever. So again, we're not writing that code. We're just saying, hey, constructor above me, deal with this information. When the object has been created with this information. And in here, we're going to do the validation on whatever the extra fields are in here for company name. Okay, this person here has an extra method code. Sorry, this class here has an extra method called coding, who prints out who doesn't love to be able to code. Okay, and then we're overriding our toString. So now we're overriding this toString, which overrides the object. So let's see what's happening in here. So in here we see this keyword super again, and it says super.toString. So what's that doing? That's calling our super class, which is person. It's calling that toString. So it's going to return person, name, whatever, and then it'll have company name plus the company name and plus this. So when we call our toString on a programmer object, it's going to call this one here. Our dancer is the same. It's called dancer. It extends person. So any of the information, any of the fields or methods that are in here, that are public or protected are going to be visible here as well. Okay, so we'll be able to access them. So again, dancing, I love to dance. Singer, we have our singer here who has a band name. They have the same fields and the same methods as here, but they also have singing and play guitar. So in here we have our band name, our extra fields, our constructor, and you can see again our super. So this is another key word that we're going to use in inheritance, and this super is calling our super constructor. So it's going to call the person constructor. It must be the first call inside our constructor. So the first thing that we do in our constructor is call our superclasses constructor. It deals with the information that's being passed, and then we deal with the information for this class. Okay. And then if we were to create this, we could create a programmer object, a singer object, and a dancer object. And you can see for the programmer we pass it the name and the company name. For the singer we pass it the name and the band name. For the dancer we pass it the name and the group name. Okay, so it's calling its own constructor. So the constructor for programmer, the constructor for singer, the constructor for dancer. Then when you call the programming object .toString, it calls the programmer objects toString. It calls the eat and the dancing. Okay, so when we call that, it'll print programming. So it'll print person name equals Joe, programmer because he was a programmer object, and the company name is Apple because that's what we said here. The next thing it says, what can a dancer do? And it says eats too much. It calls dancing and it says I love to dance. It prints out what about the singer, and then it prints out singer object .walk, probably doesn't walk enough, and play guitar only when I sing. So we were going to get into this in more detail, but you'll notice that the eat that was a method that was in person. The dancing, that was a method that was in dancer. And it's still the dancer object. When it calls eat, it looks in its own class, and if it doesn't find it, then it goes up and it finds it in the person class. The .dancing is a method in dancer, so when we call it, it's executed from the dancer class. Okay, so that there may look like it's only a small piece of information. There's a huge amount going on here. And when we start to use a real example in a second with our social network, it'll make a little bit more sense, I hope. Okay. So we'll keep going on to our next one. Okay. So introducing our subclasses. So now we're going to introduce change in social network, so we can introduce inheritance. Okay, so that's what's based on. Okay, so when we introduce inheritance, we don't just have a one level inheritance. We can have inheritance that goes down many levels. So a poodle can inherit from a dog can inherit from a mammal, and a mammal can inherit from an animal. So in animal, we'd have all of the fields and properties that all of these classes have in common. In mammal, we would have the extra fields that mammals have in common. In birds, we'd have the extra fields that birds have in common. So as we move down, we will be coming down to a more specific, we're moving from general too specific, okay? But we use the is-a relationship. So we say a poodle is a dog is a mammal is an animal. A chicken is a bird is an animal. A robin is a bird is an animal. So as we read from the bottom up, and we use the is-a. So a poodle is a dog. So that means when we go to create a poodle will have all of the information that's in dog, plus all of the information that's in mammal, plus all of the information that's in animal. Okay. But in Java, we only have single inheritance, in that we can only inherit from one class. And we'll come back to that. Okay. So a poodle inherits from dog inherits from mammal, and mammal inherits from animal. Okay. So I'd normally give you some time to try and figure this one out, but what we'll do is we'll just keep going. If you want to, you can stop it yourself and you can have a think that if you had a music format, what are the formats of music? So, I mean, I come from the analog era, so we had cassettes and vinyls. Most of you are probably a little bit younger, and you know, you're more into the digital. So you started off with CDs, and then we have, you know, data files, and we have MP4s and MP3s and different kinds of formats. Sorry, MP3. So what you would do at this stage here is, if you want, have a think about what are the different formats, and then inside of that, what are the different types of systems or hierarchy that you would note. So as I said, our music format could be analog or digital. An analog could be a cassette or a vinyl. The cassette could be a single or an album. The vinyl could be a single or an album. And then in our vinyl, we had a 7-inch or a 12-inch. So a 7-inch was the normal single, and then the 12-inch when you got the extra, it was extra big. But yeah, I can't really remember because I'm not really a music person. And then we have our digital formats. So if we were going to model this, we would have everything in the music format that's general to everything. Our analog format, we would have the extra fields that we would need to store, and then cassette, and then so on and so forth. Okay, and again, we read from the bottom up. So we have our is-a relationship, and we say that a 7-inch is a single is a vinyl is an analog format, and an analog format is a music format. Okay. So let's look at how we're going to change social network version 4 so that we can now include inheritance. So we only looked at version 4, so let's have a look. So we said that in version 4 we had a newsfeed. The newsfeed had an array list of messages and an array list of photos. And we said in it that when we went to show it, we were going to show all of the messages first and then all of the photos. So we kind of said that there was loads of code duplication. It made it difficult to maintain, and we could introduce bugs fairly quickly. Okay, so we had said when we looked at social network 4, yeah, it works, brilliant, everything is great, but there has to be a better way of doing it. Okay, so let's have a look at the better way of doing it. So now we're going to have our newsfeed. Our newsfeed is going to have a list of posts, and each post can be a message post or a photo post. So we're going to introduce inheritance. So we're going to have a class called post, we're going to have a class called message post, and a class called photo post. Message post is a post, so it extends post. Photo post is a post, so it extends post. Okay. So here is our post. So again, it has our username. We've introduced our timestamp. It has likes and it has comments. So we've added in a few extra fields along the way from version 4. So this is what we said is the information that's general to all posts. So all posts are going to have a username. All posts are going to have a timestamp. All posts are going to have a number of likes. All posts are going to have comments. A message post is going to have a message, and a photo post is going to have the file name and a caption. And then we have the getters and the setters for those. Okay, so now we're introducing our inheritance, because what did we say inheritance was? It was a way of arranging our code so we keep the general code together, and then we can have other classes that have the more specific fields to a particular class. So message post and photo post are subclasses of the superclass in this case, which is post. Subclass inherits from our superclass. So message post inherits from post. These are our common attributes. So message post and photo post will both have username, timestamp, likes and comments, but the code that deals with them is all going to be in here in post. So our subclass inherits the superclass's attributes and adds their own specific attributes. So what are we going to do? So we're going to define one superclass, post. We're going to create subclasses that are going to extend post. The superclass is going to define the attributes, the common attributes, and the subclasses, that's our message and our photo, they're going to inherit the common attributes and they're going to add their own specific attributes. So we're going to create a class called post. So then we're going to say public class message post extends post. So remember our class, our base class is going to just say public class post, and that's where all of the general information is going to be. And then when we extend it, so when we create another class that's going to inherit from it, we're going to say public class and the name of this class, and then we're going to say it extends post. So keywords that we need to remember today: extends, we use it in inheritance. It allows us access to another class by extension. We're extending it, we're inheriting from it. Okay, so we need to know when we use extend that we're inheriting. So here's our class post. So remember we said we added in a few more things. We added in a timestamp. We added in this array list of comments. Okay, so each post is now going to have a username, a timestamp, likes, and it's going to have an array list of comments. So that's like your thread with all of the different information that's going to be added in. So these are our common fields. Our subclasses is going to have all the fields that are in posts, and we're going to extend them. So that's great. So we don't have to write those again. So we just add in the extra fields. So private string file name for our photo, private string caption. So these are the extra piece of information for a photo post. And in our message post, we're going to have the extra piece of information, which is the message. So subclasses are unique. Subclass fields are unique to that subclass, and subclass objects inherit all the fields from the superclass. And it's just worth knowing as well that photo post doesn't know anything about message post, and message post doesn't know anything about photo post, but they all both extend from post. So if we look at our superclass, there's nothing unusual. It's just creating a constructor, giving it initial values. If in our time step, we're just taking in whatever the current time is in milliseconds, and we're setting our likes to 0, so we're giving it an initial value, and we're constructing our comments in an array list, so we're constructing that. Our subclass must extend post, so we want to extend this because we're inheriting from it. So that's one difference. We must call the constructor. So our first line in our constructor must be a call to our superclass's constructor, and we have to pass it the information that it requires to do its job. So when we create a message post, we're taking in the author, and if we go back here to our constructor here, we can say that our post takes in one field, a string. We store that here in our username, and then we give the other 3 fields defaults. So we get the current time, we set it to 0, and we create our array list. So that's what this super is doing. It's calling post, and then we are assigning the text to whatever the message is. Subclass constructors must always contain a super call. So we always have to call our constructor that we've inherited from, always. And it has to be the first one, okay? If none is written, this compiler inserts one without parameters, and that only works if the superclass has a constructor without parameters, okay? And the super call must be the first call in the subclass constructor. So when we are calling our superclass's constructor, it has to be first. It can't be the second, it can't be in the middle, it can't be at the end. So in our subclass's constructor, we always have to call the superclass, because we always have to create the object, and when we create the object, we need to use the fields from the general class, from the superclass. Okay. Huge amount of theory there, and until you kind of see it in action, it'll make hopefully more sense. So for today, I'm not finished yet, so don't get too excited. Just to know that we have our extends, and we use extends inheritance. It extends from a parent class, so it extends from the class above it, which is a superclass. So when we say extends, it means give me all of the fields that are in the class above it, okay? And then we add our own. The keyword super is really important because we use super inheritance, and we're calling our class above, we're calling our superclass. So we can say super open bracket like this, and that's calling our constructor. Or if we say super dot, that's when we call a method that's in our superclass, okay? Okay. And I just want to check and see, have we got time to do our last one? If not, we might leave it until Wednesday. Okay. I'm going to do the packages one. It's something that you have done in your labs before. So I'm only going to give a quick overview because I know you're at this stage pretty fed up. Okay, so packages in Java. So in your lab last week, we asked you to start using packages. And the reason for this is because there's a lot of research gone into making sure that your code is bundled together correctly. So we use folders directories in our computers for the classification of various files. So if you think of it, if you have a filing cabinet, you don't just throw everything into on the floor, or you don't just throw anything in willy-nilly. You have a system, and you put, all of the files beginning with A together, all of the files beginning with B together, all of the debt files together, all of the credit files together. So there is a system when you in your ordinary work system, how you create, how you organize yourself. And the same in Java. So packages are similar to folders, and we mainly use to organize classes and interfaces. We haven't done interfaces yet. So packages help us to write better and manageable code by preventing naming conflicts. And Java provides some built-in packages which we can use. So you have used lang and util so far, and inside of that there's classes that are related to the language, or there's classes that are related to math or whatever it is. So in our project we can use structure similar. So what we're doing is we're going to look at design patterns. There's different design patterns, but it's an important concept that you can use. So in general, it's a solution that's been given to tell you how to package or how to organize your classes. And we use the model view controller. So that's it's an important one. You can look it up yourself, but you can see that you're going to organize your classes into all of the model classes go together, all of the controller classes go together in the same package, and anything to do with the interface or the view, they'll go together in the same package. And then we can see that we create a package for our utils, and that's where we put all our helper methods as such. So we break down ours into the following. So we have our source folder, which is blue. Up until now, we have just put everything in here, but now we're going to create a package. So we're going to right click on source. We're going to create a package. We're going to call it controllers. We're going to right click on source. You're going to create a package and call it models, and on utils. And into those, you're just going to add the classes that make sense to be there. So models has the bottom level classes. So that's going to be the classes that we're creating our instance objects of, where we're storing data. In this case, product. Controllers, they contain the classes that do the heavy lifting. Okay. And in utils, we contain any utility classes. If we were using not a console based application, we probably have a folder called view, and if we had any Java FX or something like that, we'd put it in there. Okay, so now your folder is going to look a little bit like this. Okay, if we want to access all the classes and interfaces of an existing package, then we use the import statement. So we can say import package.star, or we can say import package.class name, or we can use the fully qualified name when we're calling a method in our code. Okay, so you're going to refactor your class, your shop, and I think you should have already done that, and you're going to create your packages. When you do that, you'll see that you get errors, and the reason for that is because it doesn't know, unless it's been refactored correctly, it doesn't know where everything else is. It doesn't know where product is, so it can't find it. So what you need to do is you have to import them. So you can see here that these are red because it can't find that anymore. So if you import models.product, so you can see it's in models and product. So up here if we had an import statement that says models.product and utils.scanner input, we're telling it to go to this package and that's where you'll find the product. Go to this package and that's where you'll find scanner input. And then they'll be now green. Okay, so again, we did that fairly quickly, but I kind of felt we had to because we have done that in your labs. So again, that's just organizing your code, and we live in an organized world, hopefully, and that's we organize ourselves properly. So let's organize our code properly as well. Okay, so I think I've exhausted yourselves and myself. So hopefully on Wednesday you'll be taking Inheritance a little bit further, and we'll be going into more detail about those subclasses and our superclass, and we'll be talking, I think, about polymorphism, encapsulation, abstraction, lots of those keywords that you hear the whole time, and we'll get a little bit more detail on them. So if you have any questions, pop them into Slack. Pete will be on later on tonight, and I'll be on Wednesday night, and Mairead will be in the hot seat on Wednesday. Enjoy the rest of your sunny weather. Hopefully it's still sunny outside. It's hard to tell from in here, but hopefully it's still sunny, and we'll talk to you soon.